Very good evening to all. Today we'll discuss database management system. Subject code is 22 IST 62. So this syllabus consists of different five different units: Unit 1, Unit 2, Unit 3, Unit 4, and Unit 5. So Unit 1 consists of we are giving the advantages of using DBMS data models, schemes, instance, what are the component modules, tree schema architectures, different DBMS language. We'll discuss about entity types, entity attributes, relations, ER diagrams, entity relationship diagrams. This all completely discussed in Unit 1. Unit 2 will discuss relational database design, relational model concept, what are the different constraints, different operations, unary operations, binary operations like a selection, project divisions, join operations, this all will discuss. Unit 3, like a different informal design guidelines, normalization, functional dependencies, uh, different normal forms, this all will be discussing. Unit 4 will discuss about different data types, different basis queries in SQLs, different statements, views and triggers. So Unit 5 will discuss about the introduction to transaction processing. What are the different desirable properties of transactions? So what is data actually? Data is non-fact that can be recorded and have an implicit meaning. Database is collection of related data. What is mean by database management system? It's like a software package facilitating the creation and maintenance of a computerized database. So this is a simplified database system environment. So here this is a DBMS software. So database systems, different application programs, what are the queries? It will be connecting to the database software. So then there is a metadata. So that means completely stored data definitions, more information, detailed information. So typical DBMS functionality is defining the data, constructing, manipulating the database. Whenever we require to retrieve it, modify it, accessing the database through the web applications, and processing and sharing. So main typical functionality, DBMS functionality is protection and security measures to prevent the unauthorized access, presentations and visualization of data, maintain the data. So this is an example of a database, university data. So there are different entities, students, course, sections and departments, instructors. Entities are the real world. Examples of this database, sections are a specific courses. Students takes different sections. Courses have prerequisites like courses. Instructors teaches the different sections. So these are the different relationship. How the sessions are related to course. How the student is related to sections. How the student is related to department. So this is all about the simple database, courses, sections, grade report and prerequisite. Main characteristic of the database approach, self-describing nature of the database. DBMS catalog is storing the descriptions, metadata, insulation between programs and data, program data independence, allowing the changes. So this is an example of simple database catalog, relations, columns, column name, different data types, different relations. So what is data? We have to discuss the main characteristic of the database. Data abstractions. So this is the first characteristic. Data model is used to hide the storage detail. All the details we are not showing. which are the details essential, that much only we are showing. Hiding unnecessary details like any other storage details or whatever, the unnecessary details we are hiding. Support of multiple views. Each user may see in a different views. When it comes to HOD views, it will be different. Comes to department, principal view, it will be different. Student view, faculty view, everything it will be different. So sharing of data. So we discussed about self-describing nature, share like multiple views and sharing of data. So these are the different characteristic of the DBMS. So database users. What are the different users? Database administrators, different end users, workers behind it, different designers. So this is all the categories of end users, DBMS users, database administrators, database designers, casual users, application programs. So what are the main advantages of using the database approach? Really data reducing, redundancy control. So there will be centralizing data storage, data integrity, ensuring that data is accurate, consistent and reliable. Data security, concurrent access and manipulate the data simultaneously. We have to do the backup, recovery, efficient data access, data independence. Changes in the storage structure do not affect the applications. Centralized data management, so security, integrity, concurrent access, backup, recovery, data redundancy. So repeated data we have to eliminate it. These are the different advantages. So what are the different historical development of database technology? Mainly we are using for web applications, e-commerce applications, scientific applications, data warehousing, data mining. So we'll discuss about the data models in DBMS. Data model is a conceptual framework used to describe the structure, relationship and constraint of data within the database. Helps to define how the data is storing, how the data is accessing, how the data is manipulated within the database. So data model, object-based data models are there, record-based data model, physical data models. Object-based data model, entity relationship model, object-oriented models. So record-based models, there are different hierarchical model, network models and relational models. Physical data model. So we'll discuss detail about all the models, hierarchical, networks, relational model, object-oriented model and entity relationship model. So when it comes to hierarchical data models, data is organized in a tree-like structure. So here you can see college, it's dividing department and infrastructure. Department again it's dividing into courses, teachers and students. Courses again, either it will be theory or lab. So it's like a parent-child relationship. Each child can have only one parent. So when it comes to network data model, data is represented using a graph where entities and nodes, relationships and edges. Supporting more complex many-to-many relationship. Relational model data model. Data model. Data is organized in tables, different relations where each table have rows and columns, tuples and attributes. Each table represents an entity type, uses the primary keys to uniquely identify the rows. Foreign key represent relationship between the tables. Object-oriented data models. Data is represented as an object similar to object-oriented programming, supporting classes, inheritance and polymorphism. Objects encapsulate both data and behavior. Entity relationship model. ER model is a high-level conceptual framework for data design, focusing on entities and a relationship. So entity representing the concept like different entities are student entity, course. So relationship means enrolling. Student is enrolling the course. So this is a relationship. So attribute is like different properties of an entity. Either it will be student if you are considering name, student ID, address, age, phone number. These all have the different properties. So entity relationship, two entities, how it is relating. Student studies enrolled in a course. Student and course are the entities. Enrolling is a relationship. So if you are considering student ID, name, address, phone number, these all are coming under different attributes. So courses, different course ID, course name, each course is having different ID, different course code, or like a different course name. So these all are the different properties of course. This is a ER diagram, entity relationship diagram of student joining the course. So different attributes, email, SSN, naming attribute. When it comes to courses, course ID is there, duration is there, and course title. So relation is student is joining the particular course. So we'll discuss about schema and instance. Schema is a logical structure or design of a database. It is representing how the data is organized, including table or relationship and constraints, without holding any actual data. So representing the blueprint or the framework for the database, describing the table, field, relationship and the constraints. So what is there are different types of schemas: physical schema, logical schema, and view schema. Physical schema describes the physical storage of data in the database. Storage device, including how the data is organized on the hardware. Concerned with what about the performance, what about the storage allocations. Logical schema describes the logical view. So that means what the data is stored. This is so physical schema is physical storage of data. What about the storage device? What about the file structure? What about the indexing? When it comes to logical, it is focusing on what data is stored, how the data is organized. What about the table? What about the relationship? What about the constraints? View schema represent the user specific view of database, virtual schemas. So instance refers to the actual data stored in the database. It is a snapshot of a data that adheres to the schema structure, represent the current state of a data within the database. Changes dynamically as data is inserted or updated or deleted. Relationship between schema and instance. Schema defines the structure and organization of the database. Instance is the current data stored in the database, conforming to the schema. Physical schema, logical schema, view schema. Focusing on how the data is stored physically. This is how the data is organized logically. Provide user-specific views of data. So this is an example. Schema, student table we are considering, student ID, name, age and department. Student ID is the primary key. So this is a schema of student table. When it comes to instance, so each row, each examples, at a particular instance, what is the information? So at a particular instance, now student ID is 101, name is John, age is 22, department is computer science. So we have one more row, student ID is 102, name is Jane, age is 22 and department is electronics. So this is instance. Schema is completely what are the structure, student ID, name, age and department. So what is the value for that particular instance? That is instance. Database schema versus database state. Database state is refers to the content of a database at a moment. So this is an example of database schema: student name, student number, class and major. So classes, courses, course name and course number, credit hours and department. So what are the prerequisite? Course number and prerequisite number. Section, section identifier, course number, semester, year and instructor. When it comes to grade report, student number, section identifier and grade. So this is an example of database state: course, section, grade report, and prerequisite. So then now we'll discuss about the three schema architecture. Program proposed to support the DBMS characteristic of program data independence, supporting the multiple views of data. So three schema architecture is defined the DBMS schema at three different levels: internal level schema, conceptual schema, and external schema. So internal level to describe the physical storage structures, typically uses the physical data models. Conceptual schema is completely the implementation, but I'm describing the structure, describing the constraints for all database for the community of users. External, the external level describe the various users views, usually uses the same data model as a conceptual schemes. So this is a complete the three schema architecture diagrams, very important. So external levels, conceptual levels, and internal levels. So three schema architecture mapping among schemes level needed to transform the request. Program refers to an external schema are mapped by DBMS to internal schema for the executions. What are the different data independence? Logical data independence and physical data independence. The capacity to change the conceptual schema without having to change the external schema. So we are changing the conceptual schema without changing. So we are adding some table content or something. We are adding some attributes. It's not affecting the external schema. So this is concept is logical data independence. So physical data independence, the capacity to change the internal schema. So that means we are increasing the storage capacity. So that is not affecting the conceptual schema. There is not a problem with the conceptual schema. For example, an internal schema may be changed when the certain file structures are reorganized or new indexes are created to improve the database performance. So data independence, when a schema at a lower level is changed, only the mapping between the schema and higher level schemas need to be changed in DBMS that fully support the data independence. The higher level schema themselves are unchanged. Hence the application program need not change since they refer to the external